Welcome back to the Explainer. Right now, the tech world is absolutely buzzing with agentic AI systems, and honestly, for good reason. The days of basic, single-prompt interactions, yeah, those are pretty much over. Long-running, goal-driven AI systems are stepping up and taking over. But if you've actually tried to build one of these autonomous systems yourself, you know that just finding a starting point can feel like trying to drink from a fire hose. So today, we're going to demystify modern AI agent frameworks, bring a little order to all this chaos, and take a really close look at how tools, specifically Google's modular agent development kit, are totally changing the game.
Let me guess. You recently decided you wanted to build an agentic system, right? You went out looking for the best framework to get started, and now, out of nowhere, you've got 17 GitHub tabs open, 5 Medium blogs bookmarked, and just a rising sense of existential dread. Look, it's incredibly common, and your decision fatigue is completely valid. Staring down the barrel of LangChain, AutoGen, Crew AI, Semantic Kernel, and dozens of others that are barely a year old, that is enough to give literally any developer a headache. They all promise you the world, but here's the secret. They aren't all competing to do the exact same type of tasks.
Okay, let's dive into this. Here's our roadmap for today's explainer to help reduce some of that cognitive load. First, the agent framework overload. Second, core orchestration paradigms. Third, the multi-agent ecosystem. Fourth, Google's modular AJDK toolkit. And fifth, choosing the right framework.
Section 1. The Agent Framework Overload. To figure out which framework to pick, we first need to understand the fundamental building blocks of what we're actually dealing with here.
So what exactly is an agentic framework? Well, think of it as a master toolkit that provides the essential infrastructure for your AI. This includes orchestration, like how your agents coordinate, plus tools for interacting with external APIs or databases, and memory for retaining information across a session. Unlike a simple chatbot where you just ask a question and get an answer, an agentic system handles intense, proactive coordination. It might analyze sales data, run some complex calculations, and then generate a final report all on its own. It's incredibly proactive, and it needs a rock-solid framework to manage all that complexity reliably.
Now, under the hood, an agent basically thinks using what's called the PARR cycle. First, the agent perceives its environment, taking in user input and constraints. Next, it reasons, using a large language model to plan and make decisions. Then it acts. Maybe it calls a tool or updates a database somewhere. And finally, and this is absolutely crucial, it reflects. It evaluates the outcome of its action and adjusts its future decisions to actually improve the result. This cyclical loop right here is what gives the AI its real agency.
Section 2. Core Orchestration Paradigms. Now that we've got the basic definitions out of the way, we need to look at how these frameworks actually control all that complex agent behavior under the hood. Now, what's really interesting about this slide is the stark contrast between how much control you keep versus how much freedom you hand over to the AI. Graph-based orchestration, like LangGraph, organizes agents and tools as strict nodes in a directed graph. You literally define the exact flow the agent is allowed to follow. Sure, it requires more upfront design, but it's highly deterministic and predictable, which makes it perfect for production and customer-facing apps. On the flip side, chain-based orchestration, like the original LangChain, uses dynamic loops where agents autonomously decide their next step. It's incredibly flexible and awesome for open-ended creative tasks, but let's be real, it's a lot harder to debug when things go wrong at scale.
We also have role-based orchestration, which you'll see in frameworks like Crew AI. This effectively mirrors human collaboration. You give agents specific jobs, like you're the planner, you're the researcher, you're the writer, and they work together as a team. It's a super intuitive mental model for rapid prototyping. In contrast, retrieval-centric orchestration, championed by things like Llama Index, takes a totally data-first approach. Instead of focusing on high-level autonomy first, it builds agent behavior around deep document indexing and reliable knowledge access. So your choice here really just depends entirely on whether your app is logic-heavy or data-heavy.
Section 3. The Multi-Agent Ecosystem. Let's see how all of this builds into the broader landscape. Because when multiple agents start collaborating to solve complex, open-ended problems, things get very specialized very quickly.
According to research from IBM, most agentic AI systems today fall into one of 5 buckets. Need predictability? You build a linear workflow. Got an open-ended problem, like an AI coding assistant trying to figure out a new feature? That's an autonomous multi-agent system. Need a virtual content team? Role-based systems. Moving real-world AI into operations with deep database integrations? That's production orchestration. Or maybe you're just testing an idea quickly. Then you use rapid prototyping tools with drag-and-drop canvases. You really need to match your project to one of these categories right out of the gate. And even within multi-agent setups, there's vital nuance. Take Microsoft's AutoGen versus Crew AI, for example. AutoGen is like a free-flowing, organic brainstorm. The collaboration drives the progress, and the agents just figure out how to hit a shared goal naturally. Crew AI, on the other hand, operates more like a highly structured corporate department. The agents work together, absolutely, but they have strictly defined boundaries, and they never cross into each other's specific job descriptions.
Section 4. Google's Modular ADK Toolkit. Now, as these systems grow, a lot of developers are getting frustrated with overly complex frameworks that kind of hide the underlying logic. Enter Google's Modular Multi-Agent Systems, an answer to production-ready orchestration that cuts straight through all that noise. Google's Agent Development Kit, or ADK, is an open-source, code-first Go toolkit. For developers who are just exhausted by heavy Python abstractions, where it feels like the framework is doing way too much magic behind the scenes, discovering Google's ADK is incredibly refreshing. It basically applies traditional, rigorous software development principles directly to AI agent creation.
So the crucial point here is that ADK gives developers ultimate flexibility and control. It's written in idiomatic Go, meaning it leverages Go's famous strengths in concurrency and high performance. It pushes a purely code-first development style. You define your logic, your orchestration, and your tools directly in Go, which makes it super easy to test and version control. Plus, it's deeply cloud-native, perfectly designed to be containerized and deployed seamlessly to environments like Google Cloud Run. And at its heart, it's a modular multi-agent system, allowing you to design highly scalable applications by just composing multiple specialized agents together. Basically, it means you spend way less time wrestling with framework bugs and a lot more time actually building your AI logic.
The repository itself puts it perfectly, designed to simplify building, deploying, and orchestrating agent workflows, from simple tasks to complex systems. And actually, what's really important to note here is that while the ADK is highly optimized for Google's Gemini, it remains totally model-agnostic and deployment-agnostic. That means if you're building an enterprise pipeline and need to swap models or integrate existing tools, Google's ADK is a highly adaptable, production-grade choice that absolutely won't lock you in.
Section 5. Choosing the right framework. We've covered a ton of ground today, from foundational theories to robust enterprise toolkits. Now let's bring all this source material together into one actionable matrix, so you can actually make a decision. All right, treat this slide as your visual cheat sheet. When you're looking past all the hype, you really have to stop asking which framework is best and start asking what kind of system am I trying to build. If you need strict control and high reliability, you want graph-based tools like LangGraph or OpenAI's Agents SDK. If you're building a fast, specialized agent team, grab AutoGen or Crew AI. If you want a cloud-native, high-concurrency app that interacts heavily with APIs, well, you want code-first, tool-centric toolkits like Google's ADK and Go or Fidata. And if you have strict governance and need human-in-the-loop oversight, look at Semantic Kernel. Your use case literally dictates your architecture.
So as we wrap up this explainer, I want to leave you with a final, provocative thought. As we look towards 2026 and beyond, the future of software architecture isn't about figuring out how to avoid agents. I mean, they're already here, and they're becoming foundational. The real question you have to answer is, how much autonomy are you actually willing to hand over? Because mastering the chaos isn't about building the smartest AI. It's about choosing the framework that gives you the exact right level of control. Thanks for joining me today, and I'll catch you in the next explainer.